In this video, we will look at the behavior of monomial expressions for value of x less than 0. So recall that a monomial expression is an expression of the form a times x to the n, where a is a constant value and n is a non-negative integer. So let's start by recalling some facts about multiplication. So if we have two positive numbers, so let's do that's representing a positive number. If we multiply two positive numbers together, we're always going to get a positive number back. In fact, anytime we take a positive number raised to any exponent, we're always going to get a positive number back. So multiplying positive numbers always gives us positive numbers back. But multiplying with negative numbers becomes a little trickier. So recall that if we have a negative number times another negative number, we get a positive number back. But if we do a negative number times another negative number, then these first two give us a positive number, and then doing positive times a negative gives us a negative number back. So anytime we multiply together an odd number of negative numbers, we're going to get a negative number out of that. So we can generalize that and say that if we have a negative number raised to a power of n, then that's going to be equal to a positive number if n is even, and a negative number if n is odd. So with negative numbers, some trickier things happen. We have to be attentive to whether or not n is even or n is odd. Let's look at the monomial expression x cubed. So in this applet, I have the graph of y equals x cubed, and I can vary the value of x, and this black line segment represents the corresponding value of x cubed, which is equal to y. So when x equals 2, then y will be equal to 8, because 2 cubed is equal to 2 times 2 times 2, which equals 8. On the other hand, when x equals negative 2, then y, which is equal to x cubed, will be equal to negative 8. And this is because if we if we have a negative 2 cubed, that's equal to negative 2 times negative 2 times negative 2. And if we multiply together three negative numbers, we're going to get a negative number out of that, because the first two of those negative numbers is going to give us a positive number, and then we're doing positive times negative, which gives us a negative number. So with x cubed, for values of x greater than 0, so we have x is greater than 0, then x cubed will also be greater than 0. But when x is less than 0, x cubed will be less than 0. Now let's also look at y equals negative 2 times x cubed. So the monomial negative 2 times x cubed. For any value of x, so we'll look at maybe x equals 1.5, we have x cubed is positive, and then negative 2 times x cubed should be negative 2 times as large. And so we expect to have a negative value there. And therefore, for positive values of x cubed is positive, and so negative 2x cubed should be negative. On the other hand, for negative values of x cubed is going to be negative. We decided that earlier. So then negative 2 times x cubed should be positive, because we're going to switch signs because of that negative 2. Now, let's look at the monomial x to a power of 4. So for x to a power of 4, if we have an exponent of 4, then no matter what value of x we pick, positive or negative, we should get a positive number back out. We see that from this graph of y equals x cubed. No matter what x value we pick, that value of y is going to be greater than or equal to 0. So there's no way to get a negative number out of x to the 4th. Now if we look at the monomial expression negative 2 times x to the 4th, then since x to the 4th is always positive, negative 2 times x to the 4th should always be negative. We see that from this function graph here in red, plotting y equals negative 2x to the 4th. So any value of x to the 4th is positive, and so negative 2 times x to the 4th is actually negative.